Hello everyone and welcome to Calculus. Today we are going to be studying the average value of a function and the mean value theorem for definite integrals. So this first section is mostly some rules for integration. The first one is just the main rule, which states that if you integrate f of x, and we call it capital F of x, then this becomes f of b minus f of a. That is our most basic definition. So what happens if we have the integral going from a to a? Well, that's always going to be 0. And here's why. Because you would end up with f of a minus f of a. So algebraically, you can see why that works. But graphically, you could also think about it in the sense that integral means area under a curve, which is great if you're going from a to b. But if you're going just from A to A, there is no area. You haven't moved anywhere, so there's no area under the curve. This next one is to remind us that we can take the k, a constant, out of an integral and then do the problem. And if that constant is a negative, you can take the negative out of the integral. Or if you don't want to take the negative out of the integral, another concept that's going to become very important to us is that you can reverse the integral and go from b to a, and then there's no negative in the integral. You just change the limits of integration. Because think about it, this one would become negative f of b minus f of a, where this one is going to be f of a minus f of b. But they're the same after you distribute the negative. So we're actually going to do this quite a bit. So keep this one in mind. This one's a little bit new, that you can reverse it if it's negative. If you have two separate functions, which that looks like a complicated rule, that literally could be x squared plus 2x. We don't think of those as separate functions. You think of that as one polynomial, but this could be its own function, a quadratic function, and then this could be a linear function. So in other words, if you ever need to, you are allowed to do them separately. It's really important you recognize this is not true for a product only, and then they each need their own little dx, only for addition or subtraction. This last one is saying that if you go from a to b for f of x, and then you integrate from b to c, that would be the same as integrating just straight up from a to c of f of x dx. And again, if you think about that graphically, why that works, because if you have the area under a curve from a to b plus the area under the curve from b to c, that would just be the area under the curve from a to c altogether. So these are some little rules that are generally pretty obvious. But now as I encounter them, I can remind you that we did learn it as a rule. So this next part is going to sound tricky. I actually love this section because I think that it helps prepare you for college calculus in the sense that you're going to have things like this, these 3, 7, 8, and 9, where you read something and your first thought might be, I don't know what that's saying. So what we're really practicing the skill of, because the actual information is easy once you see how it's done, we're going to practice the art of dissecting a math textbook and really understanding what it says, because you might have to do that a lot next year. If max f, that just means the maximum of f, so the maximum y value of the function f of x, and then min f are the maximum and minimum values of f. See, they even went on to explain it. On the interval a to b, so you know me, I'm always drawing my little function and I'm always going from a to b. I like to picture what I'm reading about. Then the minimum value of f. So on my picture, I'm going to make that actually a little bit bigger. A to B. So on my picture, the minimum value would be whatever that y value is, times b minus a. So what is b minus a? It's this distance right here, is less than the integral of f of x. That should make perfect sense. The minimum is the height, and this is the base. Base times height is area. So they're saying the integral is definitely greater than whatever area you get when you just do the minimum value times the width. Similarly, if I take the maximum value, so here's my A, here's my B, so my maximum value in this case happens to be at A, and I go across. So if I take that maximum value of the function, and again, I multiply it by this distance, that's really just length times width, or base times height. And the integral is definitely going to be smaller than that area. So that's all this big fancy formula is saying. Now, if you would like, you could try to read and interpret numbers 8 and 9 on your own. That would give you an opportunity to say, okay, that looks super complicated, but I'm smart and I can do it. But of course, I am going to do it for you now. Number 8 says that you have two functions. You have f of x in blue, and then I have g of x. Oh, but I did it backwards because it says, so we'll just make this one f of x. So f of x is my green one, and g of x is my blue one, and I had to switch them because I noticed that it said f of x is greater than g of x for the entire interval. So the green one has to be bigger than the blue one for the entire interval from A to B. It says if that's true, then, so this little thing kind of means then, the integral of A to B of f of x must be greater than the integral of g of x. Why do they even need to say that, right? It's so complicated, but it's easy. It's just saying that the area under the green is greater than the area under the blue because the green function is greater than the blue function. But boy, when you first look at it, you might think, oh, I'm not going to know how to do that. So if you didn't stop the video for 8, try again. Stop it for 9. See if you can figure this one out. This one just says that f of x is greater than 0, which I tend to always draw greater than 0, on A to B. Then the integral, which is the area under the curve, is also going to come out to be a number greater than 0. Remember that integral can be negative because it gives you the net area. So if this negative area is bigger than the positive area, then the integral will be a negative number. But number 9 is saying that if f of x is always above the axis, is always positive, then the integral is always going to be positive. All right, let's do some examples. These are a little bit new and different, but once people get the hang of them, they usually like them a lot. So they're giving you a much more abstract concept. This is saying that from -1 to 1, f of x is equal to 5. So from -1 to 1, this area is 5. And from 1 to 4, it's -2. So I actually am going to have to change my drawing. In order to go from 1 to 4 and to have it go down to -2, that means this 5, if that's what 5 represents, I need this area to represent -2. So I'm going to erase this a little bit. And I'm way up here, so I'm going to have to go way down. And it's okay that I left some positive, but this area and this area This is positive, this is negative, but together they make -2. And then they gave us another function on this one from -1 to 1. It's 7. Now, just to show you that it doesn't have to be always above the axis just because it's positive, it just needs to be that this positive section is bigger than this negative section. So maybe this section is 9 and this section is -2, and that would make 7. So I don't know exactly what it looks like. I just know that the net area between -1 and 1 is 7. So now it's going to ask you some questions using that information. So if I go from from 4 to 1 of f of x, well, we're not supposed to go in this direction on the number line. So here's that rule about making it negative. I can make it negative and then go from 1 to 4. And since I already know that from 1 to 4 it's equal to -2, then my answer is 2. Now they want me to go from 0 to 1. I can't go from 0 to 1. Like I was showing you on H, I don't really know how this is broken down. It could be all above the x-axis, like I did for f of x, or it could be some above and some below. So there is not enough information to do this. What about the next one? Can we go from -1 all the way to 4? So if I start at -1, I know this area is 5, and this combination is -2. So if I go all the way from -1 to 4, it'll be 3. And that's that transitive type property. Let's see, where was that one? Right here, number 6. If I go from A to B and then from B to C, then I can just go from A to C. On h of x, they've switched now. I want to go from -2 to 2. Okay, there's definitely not enough information to do that. I have no idea what happens after those points. So not enough information again. Okay, so if you want to try the last one on your own, it uses a bunch of rules that we went over in the beginning. Oh, there's 2 more. So the first thing is that I can separate this into 2 separate ones. And then the second thing I can do is I can take the constants out. Now that I've done that, I actually have everything I need to do this problem. They do each need a dx. But I know that from -1 to 1, f of x is equal to 5. So this is 2 times 5. I started to write the 10 because I know it's going to be 10. 2 times 5. And then this next one from -1 to 1 is 7. So 3 times 7. So 10 plus 21 is 31. The next one, I'm going from -1 to 4. So I can separate this. And I think I've already done from -1 to 4. I did that up here on letter C. So I just need to do -1 to 4 on the h of x. But I only actually know things about -1 to 1. So again, there is not enough information. All right, if you would like to try number 2 on your own, I highly recommend it. I'm going to quick write up the answers for you. But of course, I will do it out. But there are the answers if you'd like to try and do it on your own. So on this first one, I'm going from 0 to -3, which is not the correct order. You usually work on the number line. That's why this one is from -3 to 0. So I can just reverse it. I can make this negative from -3 to 0 of g of t. And then that's going to give me -√2. The purpose of B is to explain something called a dummy variable. You guys have actually been using dummy variables for a long time and just didn't know that that's what they were called. But every time you guys had an equation that was, say, something with a t or something like that, and you came up to me and said, Mrs. Shaffer, can I just write it as an x? And that was fine. Or if you plugged something into your calculator, of course, nobody uses the alpha button to get to a t. Everybody just exchanges it for an x. So the fact that this is a t versus a u doesn't change anything. And in AP, they're going to want to get you on this. They're going to want to see if you're confused, especially because they used the letter U, which does have other significances. But as long as it's G of the exact same thing, the U and the DU match, the answer is going to match. All right, this has a negative. You have two choices. One is you could reverse your limits of integration, which I don't want to do because I really like the order that they're in. So I'm just going to take the negative out. And when I do that, I get negative root 2 because this piece I already know. The last one looks hard. I've added a new dummy variable. Don't let that throw you. If you want to, you can just change it to a t. Doesn't matter. But they've added a square root. That's just a constant. You can't let those kinds of things throw you. Just a constant. So now I have 1 over the square root of 2 times the square root of 2, and the answer is just 1. All right, these next two are a little bit trickier. They're not in the math, just in the concept of them. Find the upper bound for the value of the integral from 0 to 2 of the square root of 1 plus cosine of x dx. Pretty much what they're saying is find the most that could possibly be. Meaning, what number would I get for an answer that I would say, well, that can't be right? Find the upper bound for it. And the way that we're going to do that is we're going to think about the maximum value of f of x times b minus a. That will give you the maximum value. So we did that right back here, maximum value, when we found the maximum possible thing that f of x could be, and we multiplied it by this distance, it gave us this rectangle. And that's what we're going to use now. This is an application of that rule. So what is the maximum value? Well, you may not recognize this function, but you do know the maximum value that cosine can be. The biggest that cosine is 1. So if the biggest cosine is 1, 1 plus 1 is 2. So the maximum value of this function is the square root of 2. And then b minus a is 2. So 2 square roots of 2 is the biggest this function that integral could possibly be. Now we're going to find the upper and the lower bounds for this function. So the upper bound is going to be determined by doing the maximum f times b minus a, and the lower bound is going to be determined by doing the minimum value f times b minus a. So b minus a is just 1 minus 0, so that was easy. And what is the maximum value that this function is? So in this case, the question is, will plugging in a 1, just because this is the maximum value, will that produce the maximum value? It actually does not. If you put a 1 in here, f of 1 is going to give you 1/2, where f of 0 is going to give you 1. So the maximum this could be is if f is 0. You want to make your denominator as small as possible to maximize the function. So you want x to be 0. So at 0, you would get 1, and so the upper bound is 1. So this integral, whatever the answer is, I don't know the answer, but now I know that it's less than 1. The minimum value, to make this function as small as possible, you want to make x as big as possible. You want the denominator to be as big as possible. So I would make it equal to 1, and that would give me 1/2. So 1/2 times, again, b minus a is just 1, is 1/2. So this is interesting. This is not an integral that you are able to solve because you don't have an x cubed in it for your du. So since you can't solve it, you might think, well, I have no idea. But yet you do. You are able to figure out that the answer is somewhere between 1/2 and 1. And that's interesting. I mean, you were really able to narrow it down. So we learned average value of a function when we did derivatives. Now we're going to do average value of a function for integration. As we look at average value of a function, before we get to the word average, what is the value of a function? The value of a function is just the y value. And average is the mean when you add them all up and divide. So try and picture a function. I know, I always draw the same function. So from A to B, the function value, the y value, keeps changing. It's up here. So let's just call that 10. And then maybe this y value is 9, and then 8, and then 7, and then 6, and then maybe back up to 7, and then maybe back up to 8. I could add up all those y values, and I could tell you the average value of the function. But those would be discrete points. What if I wanted to average all of them? 9.1. I mean, at some point, the function is 9.1, 9.2. To get to 10 by the intermediate value theorem, it was also every point in between. I want to add up all the y values, every single one of them. Well, that's what integral does. Integral adds up all the y values. If I literally added up all these numbers, I would end up getting the area under the curve. So this adds up all the y values. Now, there's an infinite number of them. You can't divide by infinity, but you can divide by this distance, b minus a. So if I integrate f of x, then I'm adding up, remember integral is sum, all the f of x's, every single y value in that stretch. And then I divide by however many there were, which is just that distance, b minus a. But nobody wants to write it this way because, of course, it looks really complicated. So I'm just going to move the b minus a out to the front and write 1 over b minus a is equal to the integral from a to b of f of x dx. This will, people in AP, guaranteed to be on the AP exam. Like I said, I'm going to teach it to you this way so it makes sense to you. But of course, this is how everybody will write the function. So it's very straightforward. Find the average value of the function. Average value of f is equal to 1 over b minus a from a to b of 3x squared minus 2x dx. You can go ahead and do that on your own. See if you can get that right. I'll do it. The answer is 16. Show me your work. So this is 1 over 3, and this integral comes out to be 3x cubed over 3, so just x cubed, minus 2x squared over 2, so just x squared, from 1 to 4. So I personally think it's easier to do the 1/3 at the end. 4 cubed is 64, minus 4 squared is 16, minus 1 cubed is 1 minus 1 squared is also 1. So that's just 0. And then 1/3 of 64 minus 16 comes out to be 16. Notice that the area of the region under the graph of f is equal to the area of the rectangle whose height is the average value. So let me explain that. If we were to actually make this graph, y is equal to 3x squared minus 2x. To graph that, of course, I would factor 3x minus 2, which would mean that my zeros were at 0 and 2/3. So right there. And let's see, what do I need to get from 1 to 4? So at 1, well, it's at 4, it's going to be all the way up at 40. So I'll make 1, something way down here. 1, 1, and it goes like this. Okay, so there's 40 way up there. So I'm going from 1 to 4, and I'm doing this area right here. Now that I know that the average value is 16, so let's just see if I can break this up easily. If that's 40, that's 20, 30, 10. I did not break that up nicely. That if 16 is somewhere around here, then from B to A, this is a height of 16 times 3. This area is the same as the whole shaded area. That's what that's saying. The area of the region under the graph of f of x is equal to the area of the rectangle whose height is the average value, which is 16. That's how they're related. All right, you can try one on your own. The answer is 1. And the answer to the second part is at x is equal to the square root of 3. So obviously I would love for you to try that on your own. For people that still need a little help, the average value formula is 1 over b minus a times the integral from a to b of f of x. That gives me 1 over 3 times 4x minus x cubed over 3 from 0 to 3, which is 1/3 times 12 minus 9 minus 0 minus 0. And then, of course, this is nothing. 12 minus 9 is 3. 1/3 of 3 is 1. And that's your average value. So the question, again, just to show you the graph, this is a slightly different question. Now it's saying, does it obtain the average value at some point on the interval? So here's my graph. It goes up to 4, has intercepts at 2 and -2. But I actually want to go all the way down because I'm going from 0 to 3. So I have a mix of above the graph and below. So I'm going from 0 to 3. Okay. My average value is 1. So look, up here, the value of the function is 4. At here, it's 3. At this point, it's 2. Right there, it's 1. Now my average value is 0. And now my average value is a negative number. And then another negative number. If I took all these numbers and added them together, I would get an average value of 1. So is there a point at which the function actually is equal to 1? Yes, right there. How do I find that? I'm just finding when 4 minus x squared is equal to 1. So 3 is equal to x squared. X is equal to plus or minus the square root of 3. There are 2 times when it has a value of 1, but on my interval, only the positive answer is correct. This that we just did is the mean value theorem. The mean value theorem says that if f is a continuous function, or I should say it's a function that's continuous just at least from a to b, then at some point c in the interval, then the average value will be equal to that y value. All right, let's practice that. By the way, we did do mean value theorem for derivatives. This is mean value theorem for integrals. Okay, suppose we have a circle of radius r centered at the origin. So here's my circle. So this is r, 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 here's 0. What is the average length of the chords perpendicular to the diameter on the x-axis? So here's the diameter that they're talking about. So to make them perpendicular would be this. A chord is something that runs from one end of the circle to the other. So this is a chord, but I don't really want that one because I only want the ones that are perpendicular to the x-axis. So all of these chords. What is their average length? So you could write the function. The function is x squared plus y squared is equal to r squared. But without any actual values, you could have a little bit of trouble. Let's see, y is equal to the square root of r squared minus x squared. It's actually plus or minus, right? That's how you get the top half of the circle and the bottom half of the circle. And so you would want to do from negative r to r, both of these integrals. I'm just going to write them together because you can only do one at a time. And what would that give you? That would give you all of these y values added up. So since I don't want to do 2 separate integrals, I could just do just the plus and then give it a 2. Think about that. Just the plus would give me just this, but if I multiplied it by 2, that would give me the other side. So 2. And then my formula for average value is 1 over b minus a. So 1 over r minus negative r. So that gives me 1 over 2r times the integral from negative r to r, 2 over r squared minus x squared. All right, how are you even going to do that integral? You can't do that integral because you don't have, if you let u be r squared minus x squared, so you can change this to something nice and easy, like u to the 1/2, you would need du is equal to negative 2x dx, and you don't have an extra x in this problem. So do you remember what to do? What do we do when we don't know how to find the actual integral? What is our backup method? Integral means area. So you can't do the actual integral, but 1 over r, really plus r now. This whole piece, this 2 square roots of r squared minus x squared, that represents, not going to be able to see that well. This represents the area of the circle. Integral means area. And can you find the area of this circle? Of course you can. So it's 1 over 2r times the area of this circle is just pi r squared. So pi r squared. So I'm going to cancel out my r's here, that one with that one, and I get pi r over 2. So again, what does that mean? It means that the average length of the chords perpendicular to the diameter. So if I actually could add up every single chord that there was and then take the average of them, obviously the longest chord is 2R and the shortest chord is 0. If I could add them all up, which is what integral does, adds them all up, and divide by how many there were, which is just this distance, 2R, I would be able to tell you their average length. So that's what I did. I added them all up by using area, and I divided by the distance, 2R, and I got pi r over 2. That's the average length of the chord. All right, we have finished this section. I hope you have a great day.